did? You did.
Prove it. So then you're going to prove it in the same way that you're going to
Just show you.
calculate any equivalent.
Some kind of haircut.
That R1 or 2 looking into that combination. You want to see what resistance do you see.
Good.
And if this is a test voltage, and this is the test current going in, R equivalent is test voltage divided by the test current. Everyone agrees about this? Is there any question why that's the case and things like that? No? Good. So how do you approach it? Yes. So you're going to do KCL and Ohm's law. So I1, I2. So who wants to volunteer for KCL and Ohm's law? Go ahead.
I2. Okay. I2 equals VT divided by VT minus 0.
VT minus 0 divided by
R2.
R2, great.
I1 equals VT minus 0 divided by R1. Yeah.
And KCL?
IT equals I1 plus I2.
Okay. So if you leave it right here, I'll give you 4 points. 8 times 5, 4 points, 80%. So if you want to continue, then just put these equations into here, and you're done. IT is equal to VT 1 over R1 plus 1 over R2. And therefore VT divided by IT is 1 over R1 plus 1 over R2 to the power of minus 1, which is that equation, R1, R2 divided by R1. Okay? So that's where it's coming from, if you didn't know it. It's coming from KCL and Ohm's law, like anything else. They all come from the same thing. Okay. Next, in the voltage amplifier model shown below, what would be the ideal RI and R out? Andrew?
I'm guessing here.
Don't. If you're gonna guess, don't tell me what it is.
Okay.
You don't know it?
No.
Okay. Corey?
R0 is, would be 0 ohms and Ri is in 10 ohms.
Sure.
That is true. Why?
Because you want the current coming out of the gain to be as high as possible, so the resistance will stay low.
Okay. In other words, I want the voltage to drop across your load, not across your output resistance, right?
Yes. You want the resistance to affect the current input load as low as possible.
And the input?
The input, you want the VI to be as high as possible, so you have the resistance to get VI to be accurate.
Did you get the answer? I'm going to repeat what he said. So if you put a source here, you put a load here. So this is VS, that's RS. Corey, can you tell me what the gain is? V out over VS?
Not off the top of my head.
So, should we use 1?
Go ahead, tell me what it is. So AB naught times
VI. A not VI times RL over RL plus RL. RS plus R over R. Yeah.
So it's the open loop gain times 2 voltage dividers, right? So if you want to maximize this gain, if you reduce R naught, this is going to become 1, like meaning 0. If you increase RI, this one is going to become 1. So RI infinity and R out 0. Questions, concerns? What would you guess, Andrew? Isn't this intuitive?
Yeah, but I've been studying signals for like the past. That's all I know about. So.
Okay. So assuming the op-amp is ideal, what is the input resistance of the inverting amplifier below? Yes,
I have a question.
go on.
Okay, so are we just supposed to have that equation memorized now then?
No. You're not supposed to memorize anything. This is how I did it. Corey didn't do it like that. Corey, did you do it like this?
No, I just did it.
He actually did it completely intuitive. That's fine by me. I did it this way because I know what the equation is. If you don't know what the equation is, you don't need it, because Corey didn't need it. So I'll tell you how Corey did it. He says the output on whatever the output is, you put a resistor in series with your output, you're dropping some of your voltage across that resistor, right? If there's a resistor, there's going to be a drop of voltage across it, right? That's going to be subtracted from the voltage that you have here, right? So the output voltage is this voltage minus that voltage. If you want the output voltage to be maximized, remove that resistor. Then there's not going to be any drop of voltage across that resistor. Completely intuitive, you don't need an equation for it. That's actually how we did it in the class too. This equation tells you the same thing. Okay? And then for the input, he said the same thing. He says, if you have a resistor here, and this is your input voltage, again, if this resistor
just for a
is
voltage
small,
amplifier.
you're going to lose a lot of voltage
This is for a
across
voltage
this voltage
amplifier.
divider.
Yeah.
If it's
If you want the
infinity,
current
all the
amplifier,
voltage is
you
going
want
to
it
drop across
be
your input resistor, which is what you want.
VRO.
So RI has to be infinity. And
Feel this.
I mean, if you
Extremely
explain
hot.
that in your exam, I'm fine. You don't need any equation.
Alright.
Now, in terms of the equation, you can actually calculate this equation quickly, really quickly. Just draw the current here and here, write the old law for both, and that's it. That's all you need, and you get that equation. In 1 minute, you can actually calculate that equation if you want to know what that equation is. But I don't care about the equation. And then, on top of all of that, if you feel like that you need an equation, ask for it. Like in the exam, you say, what's V out over VI? I'll give you the equation. Like I write it down for you. I don't care. If you know what you want, I'll give it to you. Like in the exam, you say, I don't
On
know
the
what
answer.
V out over VS is. I'll give you the equation. Yes.
RS.
You do.
That's the source resistance that you're plugging that the actual supply will have. Internal resistance that the supply will. You want RS to be as small as possible so that you.
I don't control RS.
But you do want RI.
Well, he isn't.
Bigger than RS anyway.
If
so that you
RI is infinity, it doesn't matter what RS is.
Okay. You're getting it all dropped across.
If RI is infinity, that means that there's no current passing through RS. So it doesn't matter what RS is, because there's no current passing through it. Oh, okay, who wants to do the next? Go ahead, Jason.
Okay. I just
So
said-
how do you do the input resistance?
Well, I'm wanting to do this because I don't think I did it right. I just said RI.
No, answer my question. How do you do the input resistance?
Okay, you take D, two, you assign
I'm actually
those.
explaining how you do it, right? You have to read this.
The
for
input
me.
resistance is a resistance seen by the voltage source connected to the amplifier, or in other words, VI over II.
That's it.
Okay.
So that's how you do it. VI over II is your input resistance, and that's what I'm looking for. So
Okay.
beyond that, what do?
Okay, so-
You write the KCL and Ohm law. Okay? See, there is no option. You should not think. There's no thinking. There's only one answer to all of these questions. It's KCL and Ohm law. So don't think about it. Just write it down. And then you get 80%. Okay? So this is, we call it V minus, and this is V plus. V plus is ground, so this one is going to be ground. That's an op amp, right? So that's a ground. So II, Ohm law. What's II? Who wants to do II? Michael?
Aye.
Is equal to VI minus V minus,
Which is 0.
right, over R1.
Okay. What am I looking for? I'm looking for VI divided by II. What is that?
R1.
Done. So the input resistance is R1. They said, why couldn't you do it? Whoever who didn't do it, why couldn't you do it?
Ignorant as to how that works.
Me too. Me too. I couldn't do it.
I undercompensated and just said RI input of the op amp.
Guys, this is important, okay? First of all, who did it? Who had it?
I didn't do it.
Okay, that's not
I did it by
right.
three.
So whoever that couldn't do it, you have to get to the bottom of your problem, whatever that is. I don't know why you couldn't do it. You can
gotta
come
see
to me and
someone.
explain to me, and I try to help you, but I'm not gonna be as much help as you could be to yourself. You have to look at the solution and find out which part of the solution you can't understand, you can't follow, or what it is stops you from doing this. Okay? It's too simple. And if you're not, I am almost 90% sure that most of you can't do the first part of that 4-step procedure. You don't understand the problem. Most of you, that's your problem. Like the first step, you don't understand the problem. And for that, you have to practice. You have to read more, do more, so that you do understand problems. Okay? Because the problem, actually, in the hint, I'm telling you what the problem is. Like I actually avoid any misinterpretation of the problem. I'm telling you, VI divided by II is the problem. So I shouldn't actually have to do that. But in order to make sure that you are just not coming up with any excuses that you don't understand the problem, I'll give that to you too. So beyond that is KCL, Ohm law, math. If you can't do that, do some soul searching. See what the problem is. Okay? Let's move on. In the voltage regulator below, how does reducing the internal resistance of the diode affect the regulation? Improve or deteriorate? Go ahead, Jason.
Okay, I put, this will cause a difference in output current. The load regulation changes to a different amount of current to flow through the load. Is that sufficient to explain that? Probably not.
So, what is regulation? Let's make sure that we understand the question first. What is regulation?
Control over a value.
Well, in this case, in this specific, what do I mean by regulation? Go ahead.
You want to maintain a steady voltage at that node?
Yeah, regulation means delta V out. So you want delta V out to be small when something is changing in your circuit. Okay? Delta V out 0 is 100% like the best regulation. Okay? So now I'm saying if there is an internal resistance, so there's a model for the Zener, right? It's the voltage and the resistance, RZ. So I'm saying if I reduce RZ, Is the regulation getting better or worse?
It's getting better.
Why?
More voltage.
Because as the current would get higher, there'd be a larger voltage drop across that resistance.
Exactly. I mean, the reason that you do get a delta V is that RZ. If you didn't have that RZ, you get a constant voltage. Like if that's gone, what's the voltage here? It's constant.
Yeah.
It doesn't change. So you reduce it, the regulation gets better. So I guess with that we already answered why too. Okay, if the circuit above is used as a voltage regulator and the internal resistance of the diode is assumed to be negligible, meaning that now I'm assuming RZ is equal to 0. So the model for the Xenon diode is just a 6.8 volt voltage source. What is the maximum allowable current for the user to draw from the regulator? What?
9 minus.
6.8 over RL.
What's RL? I'm asking for a current.
The current equals that, what you just said.
What is it? Like, what's the value of that?
9 minus 6.8 divided by 0.5.
Okay, so we calculate the current that flows into that node first,
It's the source current.
right?
Yes. What is it?
It's 10 minus 6.8 over.
No, it's not 10.
I use 9.
Oh,
You have
11
to use
plus
9.
I use 9. Yeah.
9.
Yeah, 9 minus 6.8.
Why is that? Why did you use 9?
Should we have the minimum?
Yeah, you calculate it for worst case scenario.
Yeah,
right?
worst case scenario.
Would you have more current on a higher voltage though?
Yes, but then if that's your maximum, so you're going to calculate a larger current, right? So if that's your maximum and the voltage drops to 9, what happens? It stops working.
Toma.
You have to calculate for the minimum.
Yeah.
The minimum is the maximum that they can draw. Because if you go from minimum above, that's fine. You have enough current. But if they go below your maximum, then it's screwed. It doesn't work. Okay?
I didn't catch that. I'm not sure what you just said there.
Okay. So how did you do it? I'll tell you.
I said 11 minus 6.8
Okay,
over.
so 11 minus 6.8 divided by
1.5.
1.5. What is that?
I don't know.
3.2.
Calculate.
Half of it.
Calculate.
I can't use mine. I borrowed.
Isn't it 6 point? Yeah. Yeah, 6.4.
8.4? 8.4 million. So that's your answer, right? Okay. So I'm going to draw 8.4 and the voltage drops to 9. What happens?
Current goes down.
If the voltage drops to 9,
Current will drop.
what happens?
The current will drop.
There's
But you said I can draw 8.4.
Maximum.
No. Yeah, exactly. That's the maximum. So I'm drawing 8.4.
Right.
But what if the voltage drops to 9? Can I still drop 8.4?
No, you just draw less. What's wrong with that? No, I'm not being funny. What's wrong with that?
You said I can draw 8.4.
Maximum.
I'm drawing
Maximum.
8.4.
Imagine you
Yeah.
have enough
What are you
source
saying?
to draw
What if it
out.
drops to
And I
9? You
want
can't have that
8.4.
one
Yeah.
anymore. Man, this
This
is
is the
funny.
rate. This is the explanation next.
What's funny?
This is the rating when you sell me this regulator and say you can draw up to 8.4, and then I start drawing 8.4, and then the voltage drops to 9,
You have
and then no
less.
longer I can draw 8.4. So why did you say 8.4?
Liar.
You have to put the time first.
Liar.
You don't rate your regulator for the best case scenario. You rate it for the worst case scenario. You say this is the maximum, and the maximum will hold at all times. It's always you can draw 8.4. Doesn't matter what. That sounds like a minimum.
No, he didn't. I don't want it. No way. I don't want it. Come on.
Minimum is the maximum. It's the maximum current that I can draw. At all times, I can draw 8.4 milliamps.
Homie already. Oh,
So if you tell them 8.4 and the voltage drops to 9 and no longer you can afford 8.4, they're gonna bring it back to you and say, you said 8.4, it doesn't work. But if you say 8.4 and actually your system can go up to 12, no one's gonna come back to you. You said 8.4, you can draw 12. So what? Good, it's better than what you asked for. Do you understand what I'm saying?
It's like the minimum maximum.
No, see, you have to think like a designer. You're selling this to me and you're saying, hey, go ahead, you can draw a maximum of 8.4. Okay? So what do you mean by that? You mean it doesn't matter what's going on, I can draw 8.4. But if your internal voltage drops to 9 and I no longer can draw 8.4, you lied to me. I can't draw 8.4.
Lawsuit.
Exactly. So you have to give me all my money back and maybe I'm gonna actually sue you because you messed something else up in my system. But if you say 8.4, and actually, most of the time I can draw more. Do you think I'm gonna come back to you and say, why did you say 8.4? This goes up to 12.
You burned my.
So what? Good. Good for you. Go draw even more. You asked for 8.4, I'm giving you 8.4.
They're gonna pay you more.
Yes.
So it's not the
I think I owe you money. You guys gonna come back? I think I owe you money, man. That thing can go to 12 million.
Sentence. So this is the output current rating on the data sheet of the regulator that you have built.
So we get the current.
You need to go over everything.
Sorry, we get the current by doing 9 minus 6.8 over the 0.5. But at that point, when you have the load RL, you still have the 6.8 volts that's going to drop across the RL. So the current.
This is IU, right?
At that point would be RL over 6.8, but we don't care about that, right? We care about what's coming out of the source. We don't. Okay. I see.
Next, assuming the diodes are ideal, what is voltage V in the circuit below? Fine.
One, right?
Who wants to do it?
One, right?
I don't know.
Is it 1 volt?
Yes,
Why?
one.
Yeah, it's correct.
Yes.
Because if that is 1 volt, that means that the other
The
diodes
organ,
have
right?
3 volts on
Yes,
3 or 2
yes,
volts on the
organ. I think
on the
it's
left
an
side, which is
organ.
higher than 1
No.
volt.
Right. So people working with high voltages wear special shoes that have thick insulating bottom layer. How does that help you?
Can you explain it one more time? One number 6 is 1 volt.
So, what is your answer? What is your answer?
5 volts.
What did you say for this?
Lots of confusion. I don't know.
I thought 0.
This is actually the way that you have to do. You have to have a yes, right?
I was gonna guess 5 volts.
5 volts. Okay, so you're saying the voltage here is going to be 5 volts, right?
Yeah.
So if the voltage here is 5 volts, what's the current passing through 1K?
0.
0. So that means that all these 3 diodes are off. That's the case, right?
Right.
So, but you have 5 volts on one side and 3 volts on this one side. This is on, 5, 2, this is on, 5, 1, this is on. So your assumption is wrong. Can't be 5 volts.
Okay.
So you go with whether or not any of these diodes is on or off. That's how you do it. Again, you say, okay, if this is on, what happens? If that's off, what happens? But then, if you practice this, you immediately see that first of all can't be 5 because, I mean, if the 5 makes all these 3 on, and then you can't short a 3 volt to a 2 volt. That's a short circuit. So it's not gonna work. So the way that, how did you do it, Jeff?
And just like that, I mean, I thought that the 3 volt would be on first.
Okay, and then you figured out if the 3 volt is on, then this one is gonna be on, that one's gonna be on, that's not gonna work, and then you go to X and
Yeah.
X, and all of a sudden you know that, well, it could be only one. So if that's one here, then this one is on,
If the diodes are the
those two
opposite,
are off.
it will be 3.
And that is actually the case,
Yeah.
because you have 3 volts on one side,
Yeah.
1 volt on the other side, and that's gonna be off, 2 volt and 1 volt, that one's gonna be off, and this one is the only one that's on. Jason?
Go ahead. I was just looking at the voltage on the right-hand side, and I said, oh, 0 volts. Then I started, this is what's going on, and I said, okay, so at 0 volts, they're all closed. They're all off. But
Okay,
you
if
need.
they're all off and you have 0 volts here, 5 minus 0 is 5 divided by 5, you
Yeah.
get 5 milliamp here. Where's that current going?
It has to go somewhere, so.
Oh,
so-
okay.
People working with high voltages use blah blah blah, what's the answer? What?
Increases the resistance to
The
their body, so
resistance
it limits the
to
current.
what?
Grounds?
So this is high voltage, that's me,
Right.
and then this is my tick.
There's no voltage.
So there, so there's not,
Nice.
there's not
So
grounded.
it limits the current that can flow through your body.
Yeah,
Why is
increases
there
your
any
resistance.
current going through my body?
Because
There
there's
might
not
be-
grounded.
There might be if there's a large voltage.
There's no potential
a lot of
difference,
current.
because there's no way for it to go.
There's no ground.
Because you are.
Yeah.
Okay,
You
this
gotta turn
thing
into
is
the
that
tube
this-
with
this
stilts.
voltage, whatever that is, 120, 1,120, whatever that is. The ground for that voltage is actually earth. How do you show that? It's earth.
Dude.
Okay? And
I know where my
I'm
phone
standing
goes to.
on earth. Okay? These are reference to earth. Actual earth. Okay? So there is a voltage difference between these two, and I'm sitting in between. So if I don't have high enough resistance,
You die.
there's gonna be a current going through me. So if I put that is in series with my body.
Right.
That resistance is in series with my body. So that's gonna limit how much current is gonna pass through me. And then I don't get killed.
Just short your whole body.
What are the voltages at nodes 1 and 3?
3 plus and
Plus 3 minus 3?
Plus
3
one.
minus 3?
Plus 1.5.
good
Plus
job.
1.5. That's right.
How did you do it, Corey?
You have 2 equal resistances, so, and the ground in the middle, so the 2.
Okay, if you did it intuitively, that's fine, but that's not what I wanted to do.
You want Ohm's law?
You could do
What?
So
Ohm's
you
law.
could do Ohm's law and everything.
You should.
Could?
You
That's
should.
not the correct answer. You should.
You should.
Okay? You don't have options unless you can do it intuitive. And in this question, actually, if you do it intuitive, I can't blame you because I didn't say don't do it intuitive. So you get the whole point if you just do it intuitive. You say, well, these are in series, you have 3 volts, so across each one is gonna be 1.5 volt drop. And therefore, if that's 0, this is gonna be plus, this one's gonna be minus, that's it. Okay?
Otherwise, drop currents, unlock, ACO. Yeah.
Okay, so it doesn't matter which way you're going. So I1, I2, and you write the case here and all, or you get it. Doesn't matter. I1 is F, blah, blah, blah. And keep in mind, I1 and I2 are equal to each other. See, because I2 is this and I1 is this. This is the same current.
Currently the same
Right?
current.
I mean,
Yeah.
the current going into the battery and coming out have to be the same. It's like a node, right? So I1 and I2 are equal to each other, and you write the KCL and Ohm's law. That's it.
That's because of the voltage source, not the resistances being the same, right?
What?
What you just said about the voltage source, that's because of the actual voltage source, not the resistance.
It has nothing to
So
do with
you
the
did
resistance. This
voltage
one is
divider?
2K and the
What,
other one
on
is
that?
1K.
Two voltage dividers?
Still,
Right there?
you're gonna get
Mhm.
I1 is
No, I
equal to
just have the voltage and put one on top, one on bottom.
Go ahead.
I just remember.
Corey, you have to. You're on time.
Yeah.
You have put together.
We took the test.
Are you here for the next class? You have put together the circuit below to get an output voltage of about 28 volt. You measure a voltage equal to 15 volts. What's the problem?
Something's
What?
Something's not connected.
What is not connected? I mean, you can't say the resistor is not connected.
Probably one of the diodes.
One of the diodes. Or more.
Is it really?
One or more of the diodes is not connected, or it's out. Like it's not working.
Okay.
You understand why, right? Because that tells you there's no current passing through the diodes. Okay?
You check polarity and then check voltage drops across the
Would it be sufficient just to check the voltage drop and not voltage increase? Make sure that it's
I mean, actually, at this point, you have to just make sure that each diode on its own is functional. Take it out, do the diode check, and then make sure that all the connections are correct. Like you don't connect it here and the next one's
Shine the
connected
laser
somewhere else.
into that thing.
So if we literally just put, is everything?
Over in the lab. It's just extremely hard
Yeah,
for
you
that
get 8
videotape.
points. I'm
Like,
sorry,
yeah,
4
just
points
like-
out of 5. Because the
Only
resistor
up
is
to 10.
connected, and that's why you get 15 volts. Okay. If your load
You can mess with
regulation
it.
changes in the output voltage as the
Turn
output
it off,
current changes,
maybe. Do it for a couple hours.
if the circuit above is not as high as what you want, what can you do to improve it?
Dude, thank you so much. Man.
More
This
diodes.
is awesome. Thank you so much, man.
Oh, no, you're welcome.
What
no,
did
no.
you say first, Andrew? Drop the resistance. Yeah.
Why is that?
Because you pass more time through your diodes, and then you have, you move your operation point to a steeper, like this exponential, right? So the higher you go, the lower the internal resistance of the diode is going to become. So the regulation gets better. See, if this is the diode, the higher you go, in terms of the current, the lower the internal resistance is.
Broke my video camera. It still works.
It
Said messed up my phone camera.
You can't record anymore?
No, I can't.
It
just
guys,
gets really
give me
hot.
the homework, the exam back.
Oh.
You don't need to keep it.
I already gave it to you. Sorry. Okay.
Yeah, like, right now. See ya.